So we will look into different types of diodes, especially the real diode and ideal diode. So what is real diode? See, real diode and ideal diode, their behaviors are almost same. The only difference is in the knee voltage and their characteristics, forward characteristic and reverse characteristic. In real diode, there is a knee voltage. That means even if you connect the real diode in forward biased, you have to supply a minimum voltage so that current can flow. That minimum voltage is called knee voltage or threshold voltage. Usually, we have been given like we will be given either silicon diode or germanium diode. If nothing is mentioned about the threshold voltage or knee voltage, we will take for silicon, we will take knee voltage as 0.7 volt, and for germanium, we will take as 0.3 volt. Okay. Whereas in ideal diode, knee voltage will be 0. That means, like as soon as you have connected the ideal diode in forward bias, it will start conducting the current irrespective of the voltage of the battery. Okay. So let us see these two with the help of some examples. Like if we connect ideal diode, so normally in ideal diode, you will not be given the name of the that diode, like whether it is made up of silicon or germanium, because it is not required. So let's say this is the diode and this is the battery. Battery is, let's say, 0.1 volt, and this diode is connected with one resistor R, that is, let's say, 10 ohm. Now, as you can see, this is forward bias. So, yes, what is the current passing through the circuit? What
0.
will
10? So 0.01.
Yes, so 0.1 by 10. So it will be 0.01 amps. This is the current that will pass through in this circuit. Okay. This is ideal diode in forward biasing.
Yes.
Now take this same thing as a real diode. So now let's say we have a real diode made up of germanium. So real diode. Now what is the current that will pass through the resistor? What is the circuit current now? Here also it is forward biased, but now now we have considered this diode to be a real diode. So what do you think? What will be the current which will pass through this resistor, or what is the circuit current in this scenario?
If it's real,
then let's say it is made up of germanium, then what?
Then we take 0.3 voltage instead of 0.1.
No, we will not take this. We will simply say that even though this diode is in forward biased, it will not conduct the current because the knee voltage for the germanium diode is 0.3 volt. So since the voltage supplied to the diode is less than 0.3 volt, current will not flow. So answer is I is equal to 0.
Okay.
Now, let us increase the battery voltage to 0.2 volt. Now also there will be no current. Okay. Now let us increase it to 0.4 volt. The moment it is 0.4 volt, now this diode will start conducting the current. And this current will be calculated by, now you see, what is the potential drop across the resistor? Already this germanium diode has, there is some potential drop across this germanium diode, which is 0.3 volt. So the remaining 0.1 volt is available with this resistor. So the current which is passing through the resistor is given by the potential drop across the resistor, which is 0.1 divided by 10. So we will get 0.01 amps. Now you see, when we have applied 0.4 volt of battery, then we are getting current of 0.01 ampere. Whereas in the previous scenario, when we have taken the ideal diode, at that time, even 0.1 voltage battery was giving the same current.
Hmm.
Understood?
Yes, sir.
Okay. Now do this question. So we have taken, let us take two circuits. We will take two real diode with battery and resistance. Everything, let us take everything same, like this one, this one. Now, okay. So this is 10 ohm. This is 10 ohm. This is, okay, let it be 10 volt. Let it be 10 volt. But this is silicon diode. This is germanium diode. What is the current passing through it? Let's say it is I1. And what is the current passing through this I2?
Okay.
So first of all, whether in the first circuit, whether current will flow?
Yes.
Yes. Okay. Then what will be current?
Yes, sir. So it'll be 10 minus 0.7 by
Yes.
10. So
Correct.
9.3 by 10. 9.0.9.
So 9.3 by 10. So it is 0.93 amps. Very good. What about I2?
That will be 10 minus 0.3 by 10. So that's 9.7 by 10, 0.97 ampere.
Yes, 0.97 ampere. So obviously in the germanium diode circuit, we will get more current because its knee voltage is less. Okay. One question you can do quickly. We have applied 0.5 volt here and 0.5 volt here. Now what is the current in these two?
In the silicon one, there will be no current
Why?
because its knee voltage is 0.7 and the given
Yes.
voltage is less than that. And in germanium, it will be 0.2 by 10, so 0.02.
Yes. 0.2 by 10, that is 0.02 amps. So this is what real diode and ideal diode does in forward biased. In fact, we can draw the graph. So for the graph of, so this is current and it is voltage. This is current. This is voltage. We will draw the forward characteristic for ideal diode and forward characteristic for real diode. So for ideal diode, the moment voltage is greater than zero, that ideal diode should conduct electricity. So we will draw like this. Whereas in real diode, until and unless a voltage does not exceed the threshold voltage, it will not conduct electricity. So let's say this is the threshold voltage. So it will go like this. It will go like this, right? This is the difference between ideal diode and real diode. There is one more character. There is one more difference in between these two diode in reverse characteristics. So that with the help of graph we can understand. So if you draw one graph like this, so this is okay. Let us draw the reverse voltage. So this is I. Now in reverse voltage, if you draw the uh, if you draw the graph of ideal diode, it will be like this. So let me use another color. So this, and then it will go like this. This is for ideal diode. There is no current in reverse biased for ideal diode. Whereas For real diode, there will be some reverse saturation current, and at breakdown voltage it will increase up to infinity. So that means for real diode, we will have a reverse saturation current, which is due to the minority charge carriers. So reverse saturation current flowing in reverse saturation current. Whereas for ideal diode, reverse saturation current will be zero. Is it okay? So this is
Yes.
what the difference between real diode and the ideal diode. Okay.
So 1 second.
Yes. So now now let us do some questions related to diode overall. What is the application of diode, like that rectifier, full wave rectifier, half wave rectifier, that we will see. Okay. So after this, we will do that.